Hey, everybody. Thanks for tuning in to the Freedom to Flourish podcast. Today, we're going to be on episode 11, where we're talking about methylation. This episode is actually going to be split up into two parts. So, we're going to have episode 11 is methylation, and part two is going to be episode 12. So, whether you're listening to it, I'll say good morning, good afternoon, good evening, whatever time of the day you're listening to this. Thanks for joining us today. Plenty of stuff to get into today. Methylation is a very, very involved process in our body where a lot of times people don't realize that it is involved in energy production, it's involved in detoxification of things like hormones, you name it, synthesis of neurotransmitters, gene suppression, and activation. Lots of stuff that goes on. So it gets a good rep for a good reason. But we're going to talk about today just the process of it and what it does and throughout all those things, all the sorts of things that go into it. So episode 2 is going to be more so involved with how we feel it is clinically significant, how you can test for it, and all the nuances there, because there's a lot of docs out there who will say, you should get tested for this. That way, but then
hmm
we have our own opinions on stuff. So we're gonna give our 2 cents. So good morning, Dr. Joel. How's it
Good
going?
morning. Good morning, Dr. Tim. Doing well. Doing well. I'm excited to get into this one. There's a lot of talk around methylation, especially lately with some different podcasts and so forth. And, you know, we talk about this from time to time, but generally there's different fads, I think, that go through healthcare. And we had the probiotic fad maybe about 10 years ago. Right now, we're kind of coming up on a kind of a cold plunge fad and a methylation fad and all these different things. So I think I'm excited for this one because I think we're going to provide a lot of insights just from our experience with methylation and really talking about, okay, we've worked with all kinds of patients. Some of them have methylation issues, some of them don't. What's it actually look like from a clinical perspective from people that are working with these patients, and what would we recommend to the average person with a lot of these things? So I'm excited. I think it's going to be very valuable for the listener. Um, I think obviously you mentioned in our part two, we're going to get into more of the kind of talking about the genetic testing and what we might recommend with some of those things and our personal thoughts on that. But I think this first one here is going to be really important because we're talking about methylation, we're talking about what it is and covering the basics, which I think it's a really complicated topic in ways. So I think if we can simplify it for people, it's going to be really valuable. So yeah, without further ado, let's jump in. So, Dr. Tim, I know we've kind of got a little bit of an outline here, but um, let's start off with what is methylation and kind of talk together about that. What is methylation, and then we'll kind of jump into the different processes it's responsible for and why it's important, and just kind of help the listener understand a little bit more about methylation in general. So I guess to start off, what I'm curious, what is your kind of explanation to patients in practice? And feel free to share a little bit about uh, the explanation of methylation you have in whatever time that you would use in practice with patients, and then also maybe more in-depth explanation. I'm curious to if that looks any different for you, and then obviously I'm happy to chime into and kind of talk about that from my perspective and experience with patients.
Yeah, absolutely. So the overarching theme that I like to use as an introduction to methylation with patients is uh, a component of methylation that is a cardiac risk marker on blood work, typically within the medical model. So that marker is homocysteine. So homocysteine is essentially a byproduct of methylation, as well as oxidative stress, all those things. That essentially it is something that the higher it is, the lower your methylation status is, and the lower methyl donors you have to do work, and the lower amount of glutathione that you have available to do work as well. And so, whenever I introduce patients to methylation, I'll just immediately jump to, okay, so on your blood work, you can see this marker homocysteine. If this is high, this can indicate that you're not methylating well, and it can also mean that you're not producing enough cysteine to help make glutathione. We've talked about glutathione in the past. It is the strongest antioxidant in your body, and at least within the allopathic realm, they look at it as if it is really, really, really high, your glutathione status is really, really low, meaning that glutathione is not cleaning up all the oxidative stress, all the garbage, all the free radicals that are floating around, and it's putting you at risk for heart attacks and strokes and all those nasty ischemic events. So that's the intro, at least. But then from there, I'll show them that, as homocysteine is converted back to methionine, there's things like, methylated folate, methylated B12, B6, B2, all those things that are going to help recycle homocysteine back to methionine. But also at the same time, all of those methyl donors are going to do things like produce creatine. They're going to help produce choline for neurotransmitter synthesis, specifically acetylcholine. It's going to help detoxify things like histamines, all that stuff. But then I also point out there's things like TMG, DMG, magnesium, all these things that actually are components of bile, where bile production is inhibited if you are not methylating properly as well. So it can help with digestion as well. So plenty of things that go into this process, and it's essentially just a cycle that has a lot of different health benefits. There's a lot of things that our body requires the methyl donors provided by methionine, as well as methylated B12, folate, all that stuff. So lots of things to uncover with methylation, but some of the other processes that it will involve are things like neurotransmitter production, detoxification, genetic silencing. And when we think about it, and when I explain it to patients, is your ability to do all those things is dictated by the status of essentially your environment. So things like caffeine is a huge thing that methylation will detoxify, and it just drains the heck out of your methyl donors. And so if you're just slamming caffeine all day, every day, how can you methylate properly? It over time is going to just drain the heck out of your methyl donors. And if you have one of the genetic snippets not working properly, and you're only methylating at, say, like 60 or 30%, then you're going to have lots of issues with a lot of different things. And so I like to try to educate patients and say that if you're experiencing a lot of seasonal allergies and you need to get rid of histamines, or if you're using up a lot of creatine and you're a big, strong power lifter, something like that, Olympic weightlifter, or even just somebody who works out a lot, or if you're not getting enough of these methylated B vitamins in your diet along with caffeine consumption, there's a lot of issues that you can have where you just won't methylate properly. So it's essentially, I know I always use this analogy with a lot of stuff, but there's the analogy where you need to essentially turn the faucet off, because your faucet can be on full blast of things that will inhibit methylation from your environment, like seasonal allergies or histamines, not getting enough in the diet, or just working out a lot. that'll drain your methyl donors, and then from there you need to make sure that the drain's unclogged, and you can actually continue through with methylation through producing neurotransmitters and creatine and all this stuff. So we need to make sure we have enough input to make sure we get the proper output, and make sure that there's not too many things that are pulling away from what we have input to it, because if there's too many things that are bogging that down, you're just not going to have enough resources to methylate properly. So that's essentially that I get in with patients. I always tie it to the glutathione stuff, as well as cysteine, and really harp on vitamin B6 in that process. So there's a lot of different supplements that people will take where it's essentially just a methylated combination B vitamin. And so it'll have activated B6, B12, B9, B2, B3, all the stuff, and then magnesium as well, usually. I don't necessarily recommend those for the most part, just because on a patient-to-patient basis, I would much rather see them in the office and make sure that they're not reacting negatively to things like B6 or B2. But for those listening at home, you could try one of those and then see how things go. And if gut issues or brain fog or anything like that arises afterwards, I would stop that pretty soon after there. But yeah, methylation's it's a great process that involves a lot of different things, and it does a lot of different yeah, it just does a lot of different things in the body that are super necessary processes. So I do think the reputation that it's getting is somewhat warranted. It's just the take that a lot of other functional medicine docs have on it isn't necessarily the same as the take I have on it. So it's a little different. We'll get into that in a little bit though. Anything that you would add to that there, Dr. Joel? Seems we might have a little connection issue. Can you hear me all right, Dr. Joel?
All right, yeah. Sorry about that, Dr. Tim. My connection is pretty rough here. I was it was pausing and all that good stuff. But yeah, thanks for that. That's awesome. It's good to hear kind of how you explain that with patients. It's very helpful for me even. Always love hearing from you. Yeah, I think for myself with patients, usually I approach methylation understanding that it's a fairly dynamic process and it impacts so many different things. I think that's why you can essentially look up methylation online and find that it's I mean, you could literally probably find some kind of website that says that it's connected to any kind of condition or symptom you're having, which is a little bit funny to me. In that, in some ways it can be true, in some ways not so much. But I think that I think in general, when it comes to any kind of condition and complaint, I think one of the things that we run into with different healthcare influencers and things like that is they'll kind of hyper focus on a certain subject or a certain topic. Some of them will hyper focus on the gut, and therefore every issue comes from the gut. And a lot of the gut is, a lot of issues do come from the gut, but not every single issue. I think the same thing happens with methylation. And I think just having the right perspective and understanding that not everything happens because of methylation issues is important to understand, but also understand, if you do have methylation issues, like here's what to look for. So I think in general, I think there's a couple of things that I mention with patients. I think number one, when I'm explaining methylation, I just try to keep it super simple. The way I explain it goes something like this. I communicate that, I'll point to the chart and kind of show them. I'll say, hey, this is a process where your body is doing a number of things, but essentially it's taking methionine, it's processing it. Methionine is an amino acid, so it comes from protein, and it turns it into homocysteine. And from there, if our body needs to use homocysteine to turn it into either cysteine or glutathione, then it'll do that. If not, it can recycle it back to methionine. And it's just this process that happens in our body with highly in our liver, but it happens with all of our cells that really just helps to increase productivity, increase efficiency with our system. So if our system needs to adapt in certain ways, it can adapt. If it needs to be more efficient in other ways, it can do that. So with that said, again, I try to keep it pretty general and pretty basic with some of those things. And I think generally that's just a great place for patients to understand that. Now, then I'll get into kind of helping patients understand how different things impact it. And so of course, always relate it back to the issue that the patient's having, whatever issue that might be. If a patient is having some kind of histamine intolerance issue, and it turns out that they need some support with methylation to break down their histamines in the liver, then I'll talk about that. And I'll also mention, hey, it's, based on what we're finding today, it's also important that you take a break from caffeine for a little bit or heavily cut back, because caffeine is always it's going to stress methylation. It's going to use up a lot of the nutrients that are needed for methylation. I'll also talk about different hormonal imbalances that they may have and how that might be impacting their histamine intolerance or impacting their methylation and vice versa. So I get into all that and try to really kind of nail it down with the patient. But, I think this is one of those processes that, obviously we're trying to simplify it for people, but it's also one that, if methylation is an issue, there's different signs and symptoms you want to look for, but it's also something that if you really want to get down to the bottom of it, you really should be working with a holistic doc that is trained in some of these different kind of biofeedback systems. So let's see, what else do I get into with methylation? I love the analogy that you share with the faucet, and then also the drain. So kind of the demand on the system, and then how much your system can handle with methylation. I think that's very important. What else do I get into with this? You touched a little bit on its importance with neurotransmitters a little bit, right? And so generally we need good methylation to support um, different neurotransmitters and so forth. I'm sure there's some other things that'll come to mind here for me because methylation is such a big topic, but I don't know, Dr. Tim, what with in regards to methylation, obviously homocysteine is important. You touched on that, and you touched on, the importance of, checking that with lab work, and that can be tied to cardiovascular health and so forth. And then obviously glutathione, which is very important. I think I don't know, Dr. Tim, what I'll kind of just pass it back off to you. With some of the things that I mentioned there, does that prompt any kind of thoughts or idea with other things that patients might bring up during our appointments and things like that?
I guess, I don't know, maybe. Most people are just like, I don't even understand this. If you tell me to lay off caffeine for this reason, you sound like you know what you're talking about, so I'm going to listen. And that's normally the response when it comes to methylation. You can say, build up a homocysteine means bad stuff, means you're not doing the good stuff properly. So take this stuff to fortify your ability to do the good stuff. That's essentially the overarching theme that I've uncovered with patients. And don't get me wrong, there's a whole wide array of patients. Every now and then you get one patient who's done a lot of research into things and is like super gung-ho about methylation.
Mm-hmm.
And so you can talk a bit more in depth in how things play in together with that. But very often in what I'll find to test during treatment is, I find one issue as it relates to methylation off of one organ system with, say, like a B12 or a B9 or like a B6 thing. But then later on, they'll have a big stress issue, and they'll test for needing like butane or trimethylglycine for the gallbladder. And then I'll just go back to it and say, well, look, this is all essentially centered around the same process, where you can find 2, 3, maybe even 4 things that trace back, trace back to the same process, just affecting different organ systems in their own respective ways. And so it ends up being a process that truly is encompassing, most aspects of somebody's health. Like, say if they've got a, chronic stress issue or chronic energy issue, chronic immune issue, whatever it is, one way or another, it very well often ties back into each complaint accordingly, and needing one aspect of methylation as a nutrient to really help with stuff. So, but the overall gist is usually just, you know what you're talking about. I'm going to do what you're going to do, or what you tell me to do, just because that is too confusing. But if you, at the end of it, say, okay, this piece is here, this piece is here, this piece is here, and this is why it relates to all your complaints, they go, oh my God, that makes so much sense. And that's perfect. But it helps. It's a great process to help bring things full circle and introduce somebody to the idea that although you have all these complaints that you haven't been able to connect the dots with and tie together, we're able to do that and show them that they're not crazy for having a million complaints. It's just different demonstrations of one process that's not functioning properly. So
Mm-hmm.
I guess that's a big component of why it's so important with explaining it to patients, and then also showing them on the chart, like, this is where these things are found, because then it just essentially they buy into it more, and trust you more. And at that point, a lot of times it makes sense that you might have one weakest link in the chain that really needs a lot of fortifying. And if you say, hey, if you used to drink 3 Monsters a day or an entire pot of coffee a day for the first 25 years of your teenage to adult life, then you're gonna have poor methylation. It's just kind of how it goes. And so a lot of things can arise from that. Thyroid issues can arise from that, autoimmunity. Lots of different things can be triggered from methylation not functioning properly. So it is a very good educational tool. Um, I think the next thing that we should really get into is just talking more in depth about how methylation accomplishes these different processes. So the next thing that I kind of wanted to get into with the creatine synthesis is how most people think of it as like a detoxification thing. Um, it's not necessarily just detoxification. Uh, Actually, 75% of the methyl donors that are produced and utilized in methylation are utilized to produce creatine. So creatine, at least how it's gained popularity nowadays within the fitness and health realm, is mostly known as a supplement that helps boost your metabolism for workouts. And I want to kind of clear some things up. Yes, it will help you produce more energy, but there are essentially two different types of anaerobic metabolism. You have your phosphocreatine system, where that is your quickest releasing um, energy production in your body. Then you have your anaerobic glycolysis that's going to produce energy there, and then you have aerobic metabolism through the Krebs cycle. So your creatine synthesis or your phosphocreatine system is going to release energy in about the first 1 to 3 seconds of say a workout. And so it's really beneficial for people like powerlifters or like CrossFitters or Olympic weightlifters, where they need energy production really quickly and for a short period of time. So it all depends on the lift and the training, but creatine will help in general and helps you regain energy quickly as well as produce it quickly. So that is the overarching function of creatine, and it's that phosphocreatine system. 75% of our methyl groups are going to go to producing this. So it is very, very, very important for energy production as it relates to very short bursts of, say, strength training. So that's the biggest piece of the puzzle. All the other things like detoxification, say, is like 10 to 15%, if even. Probably about 10%. So is the production of phosphatidylcholine for acetylcholine production, which that's also about 10%. But then as far as it goes for like genetic silencing and things like that, that's another not as heavily weighted thing that it does, but it is something that can be very important. So the steps with all these different processes, I kind of want to highlight that there's some functions with the neurotransmitter production through the phosphatidylcholine production that is very, very, very important. So phosphatidylcholine is found in your cell membranes and helps give your cells essentially integrity. It makes them resilient to different forces and things like that. And so it's actually a very important aspect of just cellular health in general for structural purposes. It also, through the choline production aspect, will help you think better. So cognitive function. Acetylcholine is the most common neurotransmitter that our body will use for both inhibitory as well as excitatory normalizing processes. So it is very, very, very important for essentially cognition as a whole and regulating thought, making sure that you can think clearly. Super important for that. It helps produce acetylcholine through that phosphatidylcholine production. But there's also something I want to touch on where dopamine and serotonin, in order to get them to their next steps, in order to, one, clear them out, and two, allow them to provide their functions beyond the neurotransmitter aspect, when they are methylated, they are turned into hormones. And so dopamine specifically will then, after it moves away from dopamine and becomes norepinephrine, it requires methyl donors to accomplish that. And norepinephrine is actually one of our stress hormones, and it's necessary to help with proper serotonin production as well. It can actually upregulate serotonin. So there's some necessary steps in there that methylation is a part of there, where it'll convert dopamine to norepinephrine and then to epinephrine if you need these stress hormones. If you have something really stressful go on, or you almost get in a car wreck, or you're getting chased by a bear, all that very acute stress is responsible for, or I guess those hormones, norepinephrine and epinephrine, are responsible for that response, where you get increased blood pressure and frequent breathing. So then that way you can route oxygen to tissues to operate at a higher level. So that's one aspect of methylating in that pathway. The other is the serotonin to melatonin pathway. So if you don't methylate properly, you can actually have poor melatonin production, where melatonin is really necessary for our proper circadian rhythm. So it is essentially a cortisol agonist or antagonist, where as the morning starts, you have cortisol that ramps up to wake you up and get you out of bed, and then it should fall throughout the day gradually. But it has an inverse relationship with melatonin. And so as the day goes on, melatonin should actually start to go up. And towards, when you get towards bedtime, melatonin, most people know it as, you take melatonin, it helps you sleep. But because it's a hormone, it's not something you should have to take. You should really just focus on fortifying your body's ability to make it on its own. So the process from serotonin to melatonin involves a few different things, but one of the biggest things is your methyl donors. So your vitamin B12, B9, all those things, as long as they're in their methylated forms, are very, very, very important for that. Let's see, what else did I want to get into here? Oh, okay. So this is actually a very important thing that most people don't realize. So methylation is involved in, like I was saying, neurotransmitter production and converting it to the hormones that allow for other functions like sleep, stress, all those things. But there's something, it's called, let's see, I want to make sure I don't butcher this. It's catechol O methyltransferase. And it is an enzyme that helps accomplish a few different things as it relates to methylation. So this enzyme is going to essentially add a methyl donor to dopamine, and it's going to essentially help decrease the amount of dopamine in circulation. So then that way you're more sensitive to it. And so it attaches that methyl donor to dopamine and helps clear it out through 3-methoxytyramine. There's a fancy word for you guys. And what it does is it clears it out of there. So then that way your dopamine pool actually starts to shrink. And we might think, okay, well, if we have less dopamine, then we're not gonna feel as good. We're not gonna be as happy. We're gonna be more depressed and anxious and all that stuff. But that's not necessarily the case. The less dopamine that you have, whenever more dopamine gets added to the system, the increase is relative to what's already there. And so it's important to think of it as relative to what's already there, because if you don't have much there already, but you get a big relative spike to it, you're going to be very, very, very sensitive to that. And so we can actually get these big spikes in dopamine where we have more sensitivity to essentially the feel-good neurotransmitter at that point. So those who have increased of activity of this COMT, or your catechol O methyltransferase enzyme, will have a smaller dopamine pool. So there's actually some personality traits that go with each one of these things. And I think it's important to touch on that, where you can actually kind of gauge your methylation status with this. So those who have actually very good methylation, very good COMT activity, they're going to have higher dopamine sensitivity. Those are the ones that have a lower dopamine pool and higher sensitivity to it. Because it's kind of up and down, you can actually get more mentally distracted, which kind of makes sense with that neurotransmitter. But it helps you detoxify estrogens, things like that, a lot more efficiently. And so a lot of these people, at least if they're women, they don't have symptoms of, say, estrogen dominance as prominently, and they tend to have more regulated cycles because of that. And they tend to be more worried about things because the dopamine will go down and then it'll surge and you'll feel really good about stuff, but then it comes right back down. Versus those who have lower activity, they have lower dopamine sensitivity, so things tend to be more level, so that they're far less sporadic with their emotions. And then from there, one thing I have written down here is things like mental stability, more focused. So tend to be more, I guess, driven towards one task at a time, or even things like OCD. Those things are very, very prominent in people who have lower COMT activity and a higher dopamine pool. So therefore, they're less sensitive to it. And then the last thing is slower estrogen detoxification. So if there are, women with low COMT activity and poor methylation, that's where more estrogen dominant type symptoms because of poor detoxification are more common. So those are the biggest things. I want to make sure I don't forget anything here. Okay, so the last few functions that I kind of want to make sure that we're touching on is so we've already talked about caffeine, histamines, homocysteine, but methylation is very, very, very important through that pathway for clearing out estrogens. And so it's very common for women who are more estrogen dominant and pushing estrogens that they have poor methylation. And so fortifying methylation will in turn help with that. The last one I want to kind of touch on is metals. So a lot of people don't realize that methylation is not necessarily just all those things we mentioned. It deals with chelating and clearing out of metals. And so the better you methylate, the less issues you can potentially have with heavy metal toxicities. So very, very important there. The overarching theme is, dealing with all those things that we already mentioned, but say that you clear estrogens out better. It's going to decrease your likelihood of getting things like estrogen-based cancers. It's going to increase your body's ability to clear things out through the liver, which is going to lead to better liver health, better cycles if you're a woman. It's going to allow for better thyroid health and essentially just better health in general. If your liver is functioning better and clearing things better, your body's going to operate at a higher level. That's just a given. Liver it's essentially the garbage disposal of everything in our body. It helps package things and process them. And if that gets backed up, your health is not going to be good. If you detoxify histamines really, really well, allergy sensitivity goes away. And so I've heard of a lot of people where even from different places locally that they're like, oh yeah, I went to this other place and they said I have a histamine intolerance. And therefore I have to be on this medication to help clear out histamines all the time. Well, if you're methylating properly and you're able to eliminate a lot of those allergens that are contributing to excess histamines, why would you continue to have hypersensitivity to things? So I guess that's where my philosophy is a little different on stuff, where if we can fortify that underlying process properly, we can have better reactions there where your allergies don't act up as much and you're not as histamine sensitive. Higher homocysteine, like we were saying before, lower glutathione status means general overall inflammation. And so higher inflammation is involved with higher risk for chronic pain, just physical pain in general, higher risk for cardiac risk, stroke risk, all those things where inflammation is just really, it's just garbage, immune garbage that our bodies need to help clear up. So there's that aspect. And then, with the metals and caffeine, you got to understand that clearing out these toxins is one of the best things for our health. If they get built up over time, it's going to affect the thyroid. It's going to affect different immune organs and can lead to autoimmunity. It's going to downregulate your thyroid. It's going to increase adrenal function. There's all kinds of stuff that's involved there that we ideally can deal with and get those things out of there and eliminate them for the most part. But then from there, we can fortify the body's ability to clear them out on its own. So plenty of stuff there where although methylation might only be involved with all those things, estrogen detox, homocysteine, metals, caffeine, all those things, you might think, okay, that's not too many things, but the downstream effects of that are a whole lot more than people realize. And so that's why methylation gets this very important rep nowadays, that there's a lot of different things that play into it. And very often, I'm sure you can add to this, Dr. Joel, very often I will find that if somebody has like a chronic immune issue or some sort of chronic liver detoxification issue, stress issue, very often I will find something one way or another that is tied into methylation as a clearance issue. And so it doesn't really matter the issue. a lot of things, metabolic issues or even immune issues, they do involve things like vitamin B6 or trimethylglycine or vitamin B12, B9, B3, B2. They have so many different processes in the body to where if you're draining that through methylation, um, it can bog down other processes. So very often in my testing, I'll find that one way or another, things from all different body systems that are affected will somehow, some way be associated with methylation. So I guess that's my soapbox with methylation. I went on for a long time,
You're
but I think
good.
it's really important to highlight that there's a lot of different aspects of what of what methylation does. Um,
Mhm.
and the last thing that we really didn't touch on too much is the genetic silencing. And there's some fancy stuff I could talk about there, but it's essentially it helps your body regulate what genes it's going to express and not express. And the better that your body can do that, the better. It's definitely better for health. So
Mhm.
just fortify your methylation so you can do that better, essentially.
Yeah.
So um, anyway, on that topic of finding things as they relate to methylation in testing so many different things in our office. Anything that you would contribute there, Dr. Joel?
Yeah, totally. Well, a couple things. Um, a couple of things. You touched on the COMT, as well as some of the other different kind of genetic markers, and it was cutting out a little bit, so forgive me for any redundancy here. But one of the things that's good to mention too here is when we talk about SNP, you might hear SNP. SNP stands for um, uh, excuse me. I just totally blanking on this right now. Singular nucleopeptide polymorphism. Is that correct, Dr. Tim? Can you verify that on for me?
I think so. I'll double check for you, but
Just to make sure that's right. Yeah, single nucleotide polymorphism. Goodness.
there you go.
And essentially, with that, we're talking about just genetic mutations, right? With some of these enzymes. So you mentioned you mentioned the COMT, which is important. Obviously, a lot of people are familiar with the 5-MTHR, the 5-methyl tetrahydrofolate. I'm sorry, that's the nutrient. The MTHFR, which is the methyl tetrahydrofolate, and then there's also the MT in the MT methyl. Oh my. All right. Whew. Sorry about that. I must not be methylating super well, Dr. Tim here. But anyways, to briefly touch on those, the MTHFR, the MTR, and the NTRR are going to be some of the other genetic things that we'll talk about in the next one, part 2, and then the PMT as well, which, from my understanding, that one's not as popular by any means. So, but a couple of things I wanted to mention on that, when we talk about methylation is, you've touched on it from so many good perspectives, a lot of good things here already. But we talk about B6 being really important. We talk about B12. We talk about 5-MTHF, which is the activated B9. We talk about B2, choline, zinc, and TMG, the trimethylglycine. One of the things that might help make sense to people is understanding that if you have such a high demand on methylation, whether you just have high caffeine intake, right, and it's more of like a lifestyle component of things that's causing these issues. Maybe you have high histamine levels and you have some kind of histamine intolerance issue because of some kind of gut infections or hormone imbalances and so forth. The demand for methylation is going to be more. And so, of course, we'll get into this in part 2 when we talk about the genetic testing and if that's really important. But at the end of the day, whether there's a genetic mutation or not, whether there's a SNP or not, it's important to understand that between internal factors, between lifestyle factors, you can increase the demand of methylation to the point where you just run yourself down on these nutrients. And you cause these nutrient deficiencies, and these nutrients are so important with all these other categories that we've talked about, making our neurotransmitters, helping with hormone detoxification, helping with glutathione production, and so forth and so forth. So understanding that the demand if that increases and supersedes the supply of nutrients, it's going to run you down on those nutrients, and it's going to cause issues elsewhere with your health. And I think that's a large reason why people see methylation being important with a lot of different issues. Yeah, the high caffeine histamines. Another thing that we'll see from time to time, if people don't have enough nutrients for this methylation pathway, if they're eating a lot of protein, that can increase the demand on things, because methionine is that amino acid that needs to be broken down and turned into homocysteine. So I've seen that very rarely, but I have seen that from time to time. So I think those are the only other things I kind of wanted to add there. But I'm excited for part 2 because a lot of people have questions about the genetic testing. What does that look like? Is it important? Should everybody be doing the genetic testing and all those things? So I'm excited to touch on that and get into that with you, Dr. Tim. All right. With all that said, I think that we've covered quite a bit here with methylation. Dr. Tim, I think, is there anything else that we needed to cover here? Anything else you wanted to add? Otherwise, I think let's wrap up and we'll see them in part 2.
Yeah, I think we should be. I think we should be good to go. There's plenty of stuff that we'll get into regarding genetic testing, and I guess more of our take clinically as to the importance and things that you can do to fortify your methylation, and things you should really keep your eyes out for. Beyond that, I think we're good for today. So we'll just talk more at next week's episode.
Sounds great. Well, Dr. Tim, where can people find you? Tell us about it.
So I am located in Bentonville, Arkansas. Practice is called Flourish Functional Wellness Center. You can find me at draugustiniak.com. That is lastname.com. No spaces or punctuation. All my socials are linked there. You can find me on Instagram, Facebook, TikTok, YouTube, all the socials, Twitter or X, formerly known as Twitter, X. You can find me on there. All that's linked through my website. So if you want to find me there. Lots of free resources on there, health articles, links to the podcast, you name it. So if anybody has any questions or is interested in suggesting topics to us, we would love that opportunity to communicate with you and get that rolling. So yeah, feel free to reach out at any of those places.
Cool. Yeah, Dr. Tim, I've already had a couple of people just kind of reaching out, asking about different things for us to talk on. So we appreciate the feedback. I'm Dr. Joel Miller here in just outside Dallas, Texas. And you can find me online at drjoelmiller.com, just drjoelmiller.com. You can also find me on the different socials, YouTube, Instagram, X, all that fun stuff. So guys, thanks so much for joining us. We love and appreciate the support. Let us know if you guys have any questions about your health, about methylation, or about another health topic, and we're happy to help. We'll see you guys in part 2, and we're looking forward to it.